What we're looking at here is the screen of a Emerson Model 375 HART communicator as it's communicating with a Rosemount Model 3051 differential pressure transmitter. To this transmitter we have applied about 500 inches of water column air pressure to the high side. It is ranged between 0 and 1,000 inches of water column, which means we're directly in the middle of its measurement range. Its corresponding analog output is about 12 milliamps, which is exactly in the middle for a 4 to 20 milliamp scale. What I'd like to do here is explore some of the features available that are accessible using the HART communicator for this transmitter. What I'm going to do to navigate is push these arrow buttons down here. Right arrow typically descends into a menu. Left arrow will back out of that menu. Up and down are self-explanatory. There are times where I'll need to touch some of the touch-sensitive screens or buttons on the screen, the soft keys, and so I'm going to use the soft plastic tip of a pen to actually push that. So first I'm going to descend into the device setup menu. I'll push the right arrow key and I see a list of options: process variables, diagnostic service, basic setup, detailed setup, and review. Process variables, at this point I'm looking at the applied pressure to the transmitter, which, as I said before, was about 500 inches of water column. That is approximately 50% range on the transmitter for a 0 to 1,000 inch range. Analog output about 11.998 or 12 milliamps. And sensor temperature, this is the ambient temperature of the differential pressure sensor. At room temperature here about 22 degrees Celsius. I can go back, go into my next menu, diagnostic service. Here I can perform various self-tests. I can test the loop, and I can also go into calibration and actually do trim adjustments for both the sensor and the D to A converter for the 4 to 20 milliamp output. The loop test is something that bears some exploration, so I'll step into that. It gives you the obligatory warning: the loop should be removed from automatic control. Choose the analog output level. What the loop test feature allows us to do is force the analog current output signal to whatever value we wish, so it will ignore the applied pressure. This is great for checking out loops that are having problems. If you want to see if there's some sort of a wiring problem or calibration problem on a device, what you can do is tell the transmitter to go directly to either 4 milliamps exactly, 20 milliamps exactly, or some other value. For example, I'll tell it to go to 4 milliamps. It says here, field device output is fixed at 4 milliamps. If we look at our loop current meter, we see that the current is now fixed at 4 milliamps. This is despite the fact we still have about 500 inches of water column pressure applied to the transmitter. It is now ignoring that applied pressure and fixing the output at 4 milliamps. Going back here, I can abort that test. Gives me another warning: loop may be returned to automatic control. I can go back into loop test and tell it to go to 20 milliamps. And it says here, field device output is fixed at 20 milliamps. And there we go. 20 milliamps indicated on our fluke meter. Now, as far as this transmitter knows, it is actually outputting 20.00 milliamps. If we see a discrepancy such as this, 20.01, it may mean that our testing instrument is out of calibration, or it may mean that the transmitter is actually outputting a little bit more current than it thinks it is, in which case we can fix that with what's called a digital trim. Let's go back to this. We'll abort that test and explore some of the other menus. Under calibration, this is a very important menu for instrument technicians. We can set the range points, which we could set from other screens too. We can do what's called an analog output trim, which tells or confirms to the transmitter what 4 and 20 milliamps looks like. For example, our last test where we forced the output to go to 20 milliamps and our fluke meter actually read 20.01 may indicate the need to do an analog output trim. We can also do a sensor trim. That's where we tell or confirm to the transmitter what certain amounts of pressure actually look like when applied to the cell. In order to do a sensor trim, I would need, in addition to the transmitter and a source of pressure like this pump, I would need some other independent pressure measuring instrument that I could use as a standard. I do not have that on this test bench, and so I will not use that. I could also go into recall factory trim. In case you think you've horribly messed up the trim setting values on the transmitter, you can recall the factory trim values that were set inside this at the time of manufacture. I can step out of this menu. I can try basic setup. Under basic setup, I have numerous options. I can give it a tag name, tell it what unit of pressure measurement to measure in, the range values, once again, one more place to set the range values. I can program various device information. I can set the transfer function. In this case, it's linear. In some cases, I may want to have the transmitter apply a square root characterization function, and that's where I would apply that. For example, stepping into that menu, I can choose linear or square root. Square root, of course, is appropriate for measuring flow through a pressure-dropping element, such as an orifice plate. In this case, I want to keep it linear. We also have damping. Damping is essentially a low-pass filter function where we tell the transmitter to ignore or to dampen any fluctuating pressures that it sees. That's helpful when you're measuring a pressure that is noisy by nature. And then we have an option here called meter options. In case your transmitter has a built-in indicator on the side, you can set some various options that the indicator can follow. Going back to the device setup menu, we also have detailed setup in case basic setup wasn't detailed enough. We can go into sensors, in which case we can configure things regarding the pressure and temperature sensor. Signal conditioning. Once again, this is a transfer function, linear versus square root. Sensor temperature unit, that's the ambient temperature sensing unit in the transmitter. We can set that for degrees Celsius or Fahrenheit. Alarm saturation levels, damping, range values, etc. We can also go into output condition and configure some things regarding the analog output, the HART output, for example, what variables are output by the HART protocol, the burst mode, for example, pole address in case it was a multi-drop transmitter, all kinds of things here. And then under detailed setup, we also have device information. We can program information about self-testing, whether or not it has diaphragm seals, information about the sensor and the materials it's made out of, things like that. So, many features, options, and parameters are accessible using one of these HART communicators. It's a world of options, far beyond what we ever had with old analog-only devices. But remember, this communicates using pulses of AC, voltage, and current superimposed on the same two wires that the DC 4 to 20 milliamp signal goes through. And I can attach this transmitter, I can attach this communicator to the transmitter directly in parallel with the transmitter or anywhere in parallel along the signal cable leading back to the power source.